Start by selecting the solid program from the Borehole Operations Lithology submenu. Next, click on the Create New Model tab. Then, select the solid to be created option. Enter Lithology 1 for the name of the numeric model that is to be interpolated. Click on the Algorithm option. These options determine which method will be used to interpolate the lithology model that is to be created. Choose the lateral blending algorithm to laterally extrude lithologies from the boreholes and randomize the horizontal contacts in the middle third distance between them. Click on the Special Options tab. Check the Superface option and select the Automatic option. This prevents the program from interpolating nodes or voxels above the top of the boreholes. To do this, RockWorks will create a grid model representing the elevations at the borehole tops or the ground surface. It will then set all model nodes above the surface to null. Note, in a later lesson, you'll use the manual filter by selecting an existing grid model. Now, click on the Subface tab. Choose the Automatic option. This will prevent the program from interpolating nodes that lie below the base of the boreholes. As with the Superface filter, this filter will automatically interpolate a grid surface based on the borehole depths or TDs. All nodes below this surface will be set to a null value, thereby rendering them invisible within diagrams and volumetric calculations. Make sure that the limiting filters within the Create New Model page are not checked. Enable the 3D Solid Diagram option. Turn on the Include Volumetrics option. Enable just the volume computations. Activating the perimeter cage will create an annotated border around the output. Enable the Legend option and turn on just the lithology. And click the green Continue button. A new RockPlot 3D tab now depicts the lithology block model. Notice that there are 3 items listed within the data portion of the tree that is located along the left side of the screen. Double-click on the Lith Solid option. A floating dialog box will appear with a list of the lithologic units. Notice that the total volume for all of the checked lithologic units is listed within this dialog. Click on the None option to disable all of the lithologies. Notice that the volume has dropped to 0. Also note that the model has disappeared. Now, enable just the sand and the silt. The volume has changed to show the total sand and silt, and the diagram has also changed to only show the sand in yellow and the silt in green. Click on the Save button within the RockPlot 3D menu and save the diagram as lithologymodel.rw3d.
When lithology fence diagrams, profiles, and sections are created in RockWorks, the program takes one slice or multiple slices through a solid model that has already been created or that is created at the same time as the diagram. Because we have already created a lithology model in Step 1, we are going to now use that model to display some additional diagrams. So choose the Lithology Fence menu option. Then, select the Use Existing Model option. Browse for the lithology1.rw mod file that was created in the previous step or exercise 4.1. Turn on the panel borders, strip logs, perimeter cage, legend, and include volumetrics. All other options should be unchecked. Click on the 3D Log Design tab. In the 3D Log Designer, turn on the title, axis, and lithology. All other strip log items should be checked off. Click on the Fence Location tab in the upper right corner of the Lithology Fence menu. You should now see the fence panels you used in the previous exercise. Erase the panels by clicking the Clear button in the toolbar above the map. This time, let's have the program draw fence panels for us. Uncheck the Snap option at the top so that the panels are not forced to the borehole locations. Click on the Hatch button in the toolbar to the left. The program will automatically draw several evenly spaced panels, trending in the northwest, southeast, and the northeast-southwest directions. Click Continue at the bottom of the menu. A new RockPlot 3D tab with the fence diagram has been added to the menu. Expand the Lith Fence option within the data tree on the left and experiment with turning different panels on and off. Click on the RockPlot 3D Save option and save the diagram as Lithology Fence.rw3d.
Select the Lithology section program. This exercise will use this program to illustrate some of the lithology modeling options. Activate the Create New Model option and change the model name to lithology2.rwmod. Click on the Section Location tab and define a section that only includes vertical boreholes. Now, click on the Algorithm tab, select the first option being closest point, and press the Continue button. Repeat this process for each of the other algorithms until you have 5 RockPlot 2D tabs along the top of the Lithology section menu. The differences between the modeling techniques are very subtle. The lateral blending is best at simulating the transgressive-regressive nature of sedimentary deposits. This is accomplished by randomizing the lateral extrusion of lithotypes within the middle third of the region between boreholes. Please note that the algorithm submenus include helpful links to documents and videos that describe these algorithms in much greater detail. You are also encouraged to experiment with the tilting and warping tools within the Special Options tab. The tilting will bias the modeling based on a regional dip. Try regenerating your section with a dip direction of 180 or due south and a dip angle of 20 degrees. You should get something that looks like this. The warping tool provides a similar functionality. Select the basement_top.rwgrd as the warping grid. This grid was automatically created in a previous exercise when we generated a stratigraphy model. For reference, we'll show the warping grid by activating the Surface Profile option and displaying it as a thick dashed red polyline. A comparison of unwarped and warped lithology models illustrates the effects of the warping. Note how the units are being warped in parallel to the thick dashed red polyline that represents the basement top grid surface. The warping is more obvious when the model is displayed as voxels in 3D, using a warping surface with greater relief.